Okay, in this video I'm going to talk about orienting the edge pieces in the last layer. Now, so far I've been talking about doing it left-handed or right-handed moves. Now what you can do is you can actually do it with all right-handed moves, but the trick is that you move the front face, or you move one of the faces and give it a turn. So what you're working with here is you're working with an empty slot, and this empty slot is here because it's essentially between two by 2 by 1 squares. Now it's obviously between the two, but if I do an F move or an R move, the empty slot is now here between these two by 2 by 2 by 1 blocks. And so all we've done is we've moved the slot around, and in the process, if you watch what this piece is doing, at the moment this piece is unoriented, this blue yellow piece. So it doesn't matter how many times I do this algorithm, we end up with it still blue side up or blue side facing us. If we put it in the front here and give it an F prime, in fact, then actually what we've done is we've moved it across, and look, what we've done is we've taken this edge, which is also the red yellow edge, which is also unable to be flipped. We've flipped that one, and in the process of doing the algorithm, we flip two edges. We can actually flip two edges by just using an F move, and we can do two at a time because we're leaving these two alone and we're exchanging these two. So that can be a useful thing to do. So in fact, the other interesting thing is if you're doing this move, then if you do it, then obviously you're switching this 2 by 2 by 2 2 by 2 by 1 block from left side to right side and moving the empty slot. In fact, because of the nature of the algorithm that we use, it only affects this edge, and this edge, and it leaves the left hand side of the cube alone. So if I take a fresh one here and we do it once, this whole block isn't touched. In fact, this square block here, this isn't touched at all. So it doesn't matter what I do, these four aren't changed. So as eventually they'll end up back, but these four aren't being touched when I'm doing the algorithm. That means that this can become our empty slot, this piece here. So in this case, what I can do is I can take an edge that's not oriented, like for example that one, and that, in fact, these two, this one's not oriented correctly either because that side doesn't match up, and this is up. So what I can do is I can go like that, and I can do our algorithm. In this case, what I would need to do is I'd need to do it forward 3 times or backwards once, because I'd want to get this piece into here and this piece up to here and back again. So we'll do it backwards. Okay, so what I've done is I've just kicked the piece from here, this piece back, this piece went to there, this piece went to there, this piece went to there. And because this square was maintained, I can then just move the block back, and look, everything's oriented. So I don't need to do any left moves anymore. So this is a nice trick. You can move essentially your empty slot around and do things right-handed. So in this case, I mean, if I do that. Okay, so now what we've got is we've got another interesting case. Remember, what we're talking about is this cycle from here to here to here. This is oriented, so we'll put an unoriented piece in the slot, and then no, sorry, we'll put an oriented piece in the slot because we're talking about moving this piece into here. Okay, so these two, for example, we move this in here, and they're now on this cycle. I can move this piece in here, like that. I move it back, and now they're oriented. And all I've done is I've moved this lot around, and it's exactly the same as if I did it this way around. What you're doing is you're moving a piece that essentially isn't. If I move this piece in, you can see definitely that it becomes twisted, and then it's on this cycle. And the same works the other way. So it becomes, well, in that case it doesn't. In that case I'm fixing it. But here, this is twisted from a right-handed perspective. So from a right-handed perspective, that's stuck. So that's the F move, and it's because you've got the original algorithm. It's just F, do the move, F prime, and that can solve all sorts of things. It's most notably known as, it's also known as the T-case OLL, orientation of the last layer, because you can take a T-case like this, where you've got one white spot, F, R algorithm, F prime. And of course you can do it the other way. There's a P case as well with a bar on this side. That is just the algorithm backwards, but with F and F prime starting and ending. So that's just a slight extension on our algorithm to help with orienting edges.